The Boeing 777 fuel system stores, manages, transfers, and delivers fuel to the engines and APU while maintaining balance and redundancy. It is highly automated but preserves manual control for pilots and maintenance. This overview follows the structure used in pilot and maintenance manuals. The 777 has 3 primary fuel tanks: left main, right main, and a center tank in the wing box. Left main tank. Right main tank. Center tank located between the mains within the wing box. Some 777-200LR and 777-300ER aircraft can carry auxiliary tanks in the cargo area for extended range. Typical total fuel capacity ranges roughly from 320 to 350,000 pounds, depending on the model. Fuel is normally burned from the center tank first, then from the wing main tanks. Each tank contains AC-powered electric fuel pumps. Each main tank typically has 2 main pumps and 1 override or jettison pump. Their purpose is to feed the engine, support crossfeed, and supply fuel for jettison. The center tank has 2 override or jettison pumps to push center tank fuel to the engines first. With center tank fuel available, these pumps provide higher pressure to override the mains automatically. Pump status and flow are monitored on EICAS and the fuel synoptic. In normal operation, each engine feeds from its respective main tank to maintain lateral balance. When the center tank has fuel, its pumps run and supply both engines directly. Once the center tank is empty, the center pumps automatically shut off. The engines then feed from their respective wing main tanks. This logic preserves balance with minimal crew input. Automation handles the flow. Pilots retain manual control when needed. A common fuel manifold runs across the airplane, connecting tank outputs to the feed lines. A crossfeed valve allows fuel from one side to feed both engines. Normally, the crossfeed valve remains closed. Uses include engine failure, single engine operation, and balancing a fuel imbalance. Open crossfeed and adjust pumps to draw from the heavy side and restore symmetry. Not all center tank fuel is reachable by the main pumps at low levels. The scavenge system uses jet pumps and ejectors powered by motive flow from the main tank pumps. It transfers remaining center tank fuel into the main tanks, recovering otherwise unusable fuel. This can reclaim several thousand pounds, improving range and efficiency. The 777 can jettison fuel in flight to reach maximum landing weight. Key components include jettison pumps, valves, and wingtip nozzles. Fuel is pumped from the tanks through a jettison manifold and out the nozzles to the atmosphere. Discharge is symmetrical to maintain balance. The system can stop automatically at a selected target or when minimum fuel levels are approached. Protections prevent dumping below minimums. Normal cruise, crossfeed closed, center first, then mains. Single engine operation. Open crossfeed to supply the operating engine. Maintenance verifies scavenge ejector performance during checks. High weight return. Jettison to reach landing weight, then secure the system. The architecture keeps the aircraft safe, balanced, and efficient, and it remains largely hands-off unless conditions demand action. Fuel quantity measurement uses capacitance probes in each tank. They determine fuel quantity, density, and temperature. Information is sent to EICAS and the fuel synoptic display. Pilots see total fuel, individual tank quantities, and fuel temperature. Fuel temperature matters because Jet A1 can freeze around -47 degrees Celsius. If temperature approaches limits, a caution appears and pilots may increase speed or descend to warm the fuel. The system normally keeps the aircraft balanced automatically. Typical alerting occurs around a 3,000-pound imbalance. Pilots can open crossfeed and adjust pumps to transfer fuel and correct imbalance. Once balanced, crossfeed is closed and normal feed resumes. From the tanks, fuel flows through a defined engine feed path. 1. Tank boost pumps. 2. The engine spar valve. 3. Engine fuel filter. 4. The engine-driven fuel pump. 5. The fuel metering unit. 6. The combustor. The spar valve is the fire shutoff. Pulling the fire handle closes it to stop fuel flow. The APU normally draws fuel from the left main tank via its own APU fuel pump. The APU can operate with very low tank quantities. Low pressure protection triggers messages, and the crew turns the affected pump off. Center tank pumps automatically shut off at low levels to prevent overheating. The fuel synoptic consolidates tank quantities, pump status, crossfeed, jettison valves, and flow paths. Design philosophy: highly automated, fail-safe, redundant, and balance protecting. In normal flight, pilots rarely touch the system beyond balance corrections, jettison, or abnormal procedures. Simple summary: the 777 has 3 main tanks. It burns the center first using override pumps, then the wing tanks, with crossfeed to supply either engine and a scavenge system to recover leftover fuel, all monitored on the fuel synoptic. That is the Boeing 777 fuel system in a nutshell.